Good afternoon, all. Right. So welcome you all for the second part of the webinar session. I hope you all can hear me clearly, right? So far we have 11 attendees. So while others are joining, let's start the lesson. Okay. So if you can't hear me well, right, you can drop a message, and in a short time of a period, you would be able to switch on your microphones, so you can raise any questions that you have during the session, or else chat is always there, right? So you would be able to send me any queries that you want to discuss with me. Okay. So according to the first session, we did the ER diagrams and we discussed few questions as well. And according to your request, today I'm going to discuss about the normalization, right? So please, children, if you can't hear my voice clearly, please let me know, right? I hope I'm audible, and I'm going to share my screen as well with you. Okay. Right. So let me share my screen. Okay, I hope it is visible for you. Right. So in order to make things more easier, here I'm going to use a small presentation regarding the normalization, right? And meanwhile, I'm switching to the whiteboard and I'm going to demonstrate some questions for you. Right, let's do some questions, and meanwhile, I'm going to switch to my whiteboard to demonstrate some ideas, right, where we want to discuss more, right? So the main thing that I'm going to discuss, the normalization. When I'm going through your syllabus, I have seen that you are discussing about the three normalization forms, right, which is available in your syllabus. That is the first normal form, and the second normal form, and the third normal form, right? And we when you're if you're going to continue your studies from the computer science, right, you would learn another normalization form, which is known as the fourth one. We are not saying it as the fourth normal form. We are having a separate name for that. That is the BCNF, right? Voice code normal form, right? So I'm going to teach that one as well. That is really easy, pretty much easy. That means once you have completed up to third normal form, that is on the BCNF, right? So we have to just recheck it. That's it, right? So children, let's see what is this normalization, right? So let me put it to the right. Okay. So children, normalization. What is this normalization? It is a technique of organizing the data in the database, right? We could say in simple terms, it is a technique of organizing the data, right, in a database. We know we can call a database as a collection of data, right? Inside the database, we have data, right? So this normalization is what? It is a technique that we are going to use in order to organize the data inside the database, right? So that's the idea. It's a small technique. It's not a big thing. It's a small technique. And this technique is helping us to organize the data inside the database, right? And let's see why we need normalization, right? So if we don't have this particular normalization technique, right, okay, it becomes difficult to handle the database data, right? So it says it difficult to handle and update the database without facing data loss. Let's say we have very valuable set of data, right? And very valuable. Think about the organizations. Let's say organization is maintaining their employee details within the database, right? So when we are going to update the database, we are losing data. Then what will happen? We will lose our valuable set of information, right? So why it is happening? Because that database is not properly normalized, That's the idea, right? So normalization would help you to organize the data in a database in a proper way, and it will eliminate all the problems, like see difficulties and the problems available with the databases, and it will ensure that you don't lose any data inside the database. That's the idea, right? So children, I'm taking an example, right? You can see this is a relation, right? Relation name is the lecturer, right? And we have different fields in this relation, right? ID, name, address, salary, department number, department name, and the building. So this is another field, right? So here lecturer is the relation name, and we have few fields, ID, name, address, salary, department number, department name, and the building, right? Okay, so I'll show you a sample data set for this, right? Okay, so I have added sample data for this particular table. This table is inside the database, right? So here you could see ID, I have taken 001, and the name is Anne, Candy is the address, salary, and then department number is there, department name, computing, and the building name. It's available. And we have another record, the ID is 2, and we have all these fields available, and the building city campus, and then we have the ID 3, and we have the name, address, and the salary information, department number, the same department, computing, and the building name. And we have another record right here, the 4th record, ID is 4, and then we have all the records here, and the department number is 3, that is the department, the law department, and the building name is the access tower. So like that we have records now, right? So within an organization, normally we don't have just 4 records, right? Okay, we have many number of records. Let's say we have 100 plus employees, 150 employees, then we might have 150 records, right? In this particular table, the relation called lecturer, right? So now this database, right? The database which is available, the table which is available, right? It is not a normalized table or normalized database. So here we have not done any normalization, right? So because of that, I told you when we're handling data, or when we're going to update the data, right, we might end up with a data loss, right? So in that case, we could face with 3 different anomalies, right? If we don't have a normalized database, most of the time, right, DBA, the database administrator who's working with the database, okay, can face with 3 different anomalies, right? So the first anomaly would be the insertion anomaly. Let's see what is that. And the second anomaly would be the deletion anomaly. And then third anomaly would be the update anomaly, right? So let's see what is this insertion anomaly, right? So here, I told you, this particular database is not normalized database, right? So if you're going to insert another record, let's say we have another lecturer who is working under the computing department, right? So we might insert, okay, we might insert 0, and let's say Peter, right, from Candy, okay, and let's say salary is this, and the same department 01 computing, and if it is the computing department, okay, that is the building name is Candy Campus, right? So we got an anomaly now. What is the anomaly? The same data, see, department number 01, department name, computing, building, Candy Campus. These are repeating again and again, data redundancy. See, even Anne is working under the computing department, and also Jane is also working under the computing department. This Peter also working under the computing department. So when we are inserting data or the rows or the tuples to this particular table, what will happen? The same type of data is going to be redundant, right? See, 0, 1, 0, 1, 0, 1. The department number is redundant now. And not only the number, right? Name and the building, right? So data redundancy is there, right? We like as a database administrator, what we're supposed to do is we're supposed to avoid data redundancy, right? What is the purpose of having a database with data redundancy? If we are maintaining a lot of duplicate data inside the database, that is not a proper database, right? So we have the insertion anomaly now, right? So according to the lecture slide, you would be able to see here, it says, okay, as we discussed, this is the insertion anomaly, right? And here, see, ensure that correct department information is inserted, right? And also another thing is available, right? Another thing is available. Let's say now this data entry operator, right? Instead of inserting computing like this, is going to insert the computing like this, or from caps like this. So here, same department number is same, department 1, but you have two different names. So data inconsistency is available, right? So here, see, same department, but you have different two names, right? Computer, it doesn't understand, okay, these two are same thing. Why? This is from starting from caps, and then other letters we have them all simple, but here we have caps lock letters. Then what will happen? Computer cannot understand whether these two are same or not, right? Think about an SQL query. You want to retrieve the lecturers, right? You want to retrieve the lecturers who are working. You want to retrieve the lecturer's name who are working in the computing department. So then we supposed to give what, right? We supposed to give select all. No, select, okay, let's say name. Okay, we are interested about the names. Select name from the lecturer relation. Where? What? D name. What you supposed to give? Is it this computing? If we give it like this, right? So it will retrieve only Anne and Jane, not the Peter, right? So what we have, data inconsistency also available, right? Even redundancy and also the inconsistency, right? So this is the insertion anomaly that we have, right? So this is a problem, right? This is a problem. We are not getting the correct set of data, right? I mean, it is a problem of handling the database. So this is an unnormalized database. So we can face with this particular problem, which is known as the insertion anomaly. And the next one I told you, that is the deletion anomaly, right? Let's say now Lily, right? The lecturer Lily, right, is going to leave this particular organization, right? Now she is going to leave the organization, right? Once she left the organization, right, no longer the organization is not going to be interested on her record, right? What we are going to do is we are going to delete this particular, okay, it is not erasing, so I'm going to delete this particular record, right? We want to delete it. Now what will happen? Okay, once we deleted this particular Lily's record, right, we are deleting the department details as well, because for the low department we had just one lecturer, right? Now we are clueless whether we have a low department or not inside the organization. Why? That records are not available, right? Those records are not available. See, right, we can't find any department called low, but it's there, right? So this is known as what? Deletion anomaly. Okay, right? So we understood, okay, we are getting the insertion anomaly as well as deletion anomaly, right? And let's say, what is this update anomaly, right? Let's say now, okay, this department, the computing department, it's inside the Candy campus, right? Let's say now the organization has changed the location of this Candy campus, right? They have changed the location and they have renamed the building, right? They have gone for another building. Let's say Peradeniya. Now they want to name it as a Peradeniya campus. Let's say something like that, where are the new city campus or something like that. Okay, now like when we are going to update it, right, see how many records that we supposed to update. We have to update this particular place, right, and we have to update this particular place, and we have to update this particular place, right. And let's say if we have 150 employees who are working under the computing department, we have to update 150 records individually, right? Because we have to change the building name because campus, they have relocated, right? So this is update anomaly, right? So here, like why we are using some kind of a database, because like we want to make our things more easier, right? We are not developing systems to make our things more worse, right? Like if the process is very easy, only users are tend to use the system or tend to use the databases, right? So here now this is an unnormalized, right? Okay, an unnormalized database. So here we have three different anomalies, right? Insertion anomaly, as well as what? Deletion anomaly, as well as updating anomaly. Okay, so these are the three anomalies that we could get, right, during this unnormalized, if we have some kind of an unnormalized database, right? So children, I hope it is clear for you, right? Please ask questions if it is not clear regarding the like what anomalies that we were discussed. Yeah. Any questions? So if so, please like you can use the chat. Yeah, or you can raise your hand. Right. Is it clear up to this point, like what is this normalization and why we need this normalization, right? This is not a like some kind of a like rocket science or anything, right? Just a normal thing, like which we are using to like normalize a database, right? Because normalization is a technique, right? We need to understand that it is a technique. We can like organize data inside the database. Okay, thank you, Nuhansa. Okay, right. So I hope it is clear for everyone. Okay. So now let's see what are the normal forms available, right? Normalization rules or the normal forms available, right, in the DBMS, right? So we have, like I told you when I'm starting the session, right? I mentioned that in your syllabus, you have three normal forms, right? And when you're like learning further, right? If you want to learn further, you in under the computer science stream, you will learn another like normal form called BCNF, voice code normal form, right? So we have four normalization rules, normal forms, right? First normal form, second normal form, third normal form, and the BCNF, right? We can write these things in a like shorter way, right? First normal form, we can write it like 1NF, right? The same thing, right? First normal form, we would be able to write it like this as well in a shorter form, right? And second normal form, this is how we supposed to write it. Sorry for that. Okay, see, second normal form, and the third normal form, it is like this. Sorry for that. Okay, and the BCNF, we can write it like this, and the like the term BCNF stands for voice code normal form. That's the idea, right? So now let's see one by one, right? Let's see what is this first normal form and the second normal form and the third normal form, and then at last let's see what is this BCNF, right? So let's move with the first normal form, right? Okay. Now I mean, in your syllabus they are not asking what is this first normal form, and if it is in the first normal form, right, what are the like characteristics, they are not asking that thing. Like I mean, they are giving, like I have seen few questions, they are giving a table and you supposed to write whether the like relation is in which normal form. You're supposed to identify what is the normal form it is in and what is the next normal form that you can convert it, right? And then you have to provide the justification why you say it is in the first normal form or the second normal form or the third normal form, right? You have to provide a proper justification. That's it, right? So in order to understand this, let's see what is this first normal form, right? Okay, what is this first normal form? It says if a relation or a table, we know in a relational database terminology, we are not using the term called table, we call it as a relation, right? So this is a relation. See, this is a student relation, right? You can see student field is there, age field is there, subject field is there. We could say student detail relation. We can give a name for the table called student details, right? So normally in a relational database, we are calling a table as a relation, right? Okay, so this is student detail relation, right? So in this relation, if it is in the if the relation, right, is in the normal form, right, if domains of all attributes in the relation are atomic or simple and indivisible, what is that, right? So now you could identify these are attributes. Student details relation, student is an attribute, right? Okay, and age is an attribute, right? Subject is an attribute. We know that, right? And domain of all attributes. This student, we have names. This Adam is the domain, right? Age 15 is the domain, right? Subject biology maths, it's a domain, right? These domains should be atomic domains, right? We cannot have multiple values like this. Look at this one. Student Adam, age is 15, and he's following two particular subjects. One subject is the biology and the other one is the maths. So here in a particular attribute, we cannot have multiple values like this, multiple domain like this. Domain should be simple and indivisible like this. See, just one. Okay, so if you are getting a table like this, table with you have a column or you have an attribute or you have a field with multiple values like this, so that relation is not in the first normal form. That's the idea, right? What is that? Again, I'm repeating. If you are getting a relation, right, which is having multiple values for a domain, right, under any attribute, right? Multiple values like that, like this in a domain for the domain. So this relation is not in the first normal form, right? It is not in the first normal form. It has not started the normalization process even, right? So if I take this particular relation, they have not performed any normalization theory. Right? Okay. So now what is the next normal form? We can make it as first normal form. That's the idea. So how we can make it as a first normal form? Now it clearly says, right? Okay, we are having a question. Yeah, multivalue attributes. If you have multivalue attributes, right, like this, right, this relation is not in the what? First normal form, right? Okay, if you have multivalued attributes like this relation is not in the first normal form. But if you can remember, when you're mapping your ER diagram, if you know the correct theory of mapping a multivalue attribute into a relational mapping, if you know the correct theory, you won't get any tables like this. You won't get any relations like this. Once I told you, if you can remember on my last session, yeah, I told you if you have followed all the ER diagram rules, right, correctly, right, you won't get any unnormalized tables. That's the idea, right? So sometimes if you miss something in the ER diagram, so you will get these sort of tables. That's the idea. So multi-value attributes, yes, right? So if we here the multi-value attribute, this could be a telephone number, right? Okay, see, you have student, age and the telephone number. Under telephone number, you have a lot of values, right? So this is not in the first normal form. So let's see how we can make it into the first normal form. Okay, so once we my slides are not moving, let me check. Okay, right. So here, once you converted your relation into what? First normal form. So what we can do is we can have multiple rows for the values, for different values. See, can you remember Adam? Adam is following two different subjects. So I have put two rows for Adam like this. Adam, age is 15, biology. Adam, age is 15, maths. See, Alex was the other, like, see, the row we had, and the Stuart, right? So here, look at this one. Now we have added two rows for Adam because he's following two different subjects. That's the idea. I have another example. Look at this, right? Course right here, and we have the content here available. The next one, course is the programming, content is Java and C++, right? And course is web. We have HTML, PHP, and ASP. So this is not in what? First normal form, this one, right? So after converting to, right, first normal form, right, this is how we can go ahead. We have the course and content, and then for programming we have two records, two tuples, like this: programming Java, programming C++. And web we have three values. So because of that, web HTML, web PHP, web ASP, like that we can have, right? So now children, can you identify any problem here? Right now this table, it's in the first normal form now. First normal form rule is okay, right? See, domain, just atomic value, indivisible, just one value, programming, just one value, Java, programming, C++, see, just one value, right? Yeah, any problem? Yes, right. Some courses are repeating again, duplication of data. Yes, we have heavy data duplication now. See, programming, web, right? Heavy data duplication is there. But if we take these two together, programming Java, together, it is unique. Even though we have duplicated data, like there is no way to identify them, right? So now what is the primary key that you're going to select? We can't select any primary key, right? So then what we can do is we can make these two things as a primary key. So if we make it combine the both fields, then it is unique, right? But here we have heavy data duplication, right? So here it's data redundancy increases further, right? As there will be many columns with same data in multiple rows, right? See, same data, programming, web, same data, right? And but each row as a whole will be unique, right? Okay. So then what is the characteristics of a first normal form? You have to understand this very clearly, right? If you have atomic domain values, right, in your relation, like this, atomic domain value. See, atomic domain value. Further, we cannot divide it. Java, it's just one value. But here, these are not atomic. We can further divide it. HTML is a different thing. PHP is a different thing. ASP is a different thing. We can divide it, right? Divisible, right? Okay. So if you have like domains, like attributes with domains, right? Indivisible domains or the atomic domains, that particular table, you can guarantee that is on the first normal form, right? That's the idea. So we understood that, right? That is in the first normal form, right? So what is the rule? The rule should be what? Your relation, right? Okay. A relation R is in first normal form if domains of all the attributes, the student attribute, age attribute, subject attribute, in the relation are atomic, that means maybe simple or indivisible. Then you could guarantee, okay, this is in the first normal form. See, this is in the first normal form. See, all are atomic values, right? So this is also in first normal form, right? So children, do you have any questions there, like in the first normal form? Is it clear? Any questions? Anything that you want to ask? Okay. Thanks, Disara. So why I'm not switching on my camera today, because I'm experiencing a power cut, right? Still, like all the academics at APIIT, we are like working from home, but IT department and the marketing department and the management, they are like moving to office, right? But today I'm experiencing a power cut, so I have a bad lighting setup here. So that's why like I'm not switching on my camera today. Okay. So next week, let's see, most of the time I would be available at office. Okay. Right. So let's see the second normal form, right? Right. Okay. We discussed this as well. Right. So let's see, what is this second normal form? Here, if a relation, now you have a relation in front of you, right? Let's say something like that. Let's imagine something like that. You have a relation in front of you, right? And in order to check whether this given relation is in, right, second normal form, right? First, it should satisfy the first normal form, right? So these are like steps, right? In order to move to the second normal form, first you need to satisfy the first normal form. That means you don't have any like multi-value attributes with you, right? All like attributes domains are atomic. So that is for sure. Okay, first normal form done. Okay, so in order to be inside the second normal form, you have to satisfy the first criteria, first normal form. And right, you have to satisfy the first normal form. It says and, okay, see, and, right, every non-prime attribute A in R is not partially dependent on any key of R. I know like this is not very clear to you, right? I'll take some examples and let you know. Okay, so here we have another new word called non-prime attributes, right? Children, we have two types of attributes, right? Within a relation, we have prime attributes as well as non-prime attributes, right? So I'll take one example, right? Okay, let me take the whiteboard. I'll use this one. Okay, let's say we have a relation called what? Let's say employee. They have employee relation, right? And there, let's say we have EMPID, employee ID, right? And let's say NIC, that's the national identity card. And let's say EMP name, employee name, right? And let's say EMPH, okay, right? Let's say this is the relation. And here, these two are the primary keys, right? So DBA can decide on, okay, what are the primary keys that you're going to include, right? So here I have selected these two primary keys, right? So we have two terms now, right? The first term is prime attributes. Okay, prime attributes. Okay, prime attributes means any attribute, right, which are participating for the primary key is known as prime attributes. Sometimes it could be two, it could be one or more, right? See, prime attribute means any attribute which is participating for the primary key, right? Here, just use your chat and send me what are the prime attributes available in this particular employee relation. Yeah, just tell me what are the prime attributes. Yeah, we got an answer. Yes, EMPID and the NIC. Yes, good, right? So here, according to this example, we have two prime attributes. One is the EMPID and the NIC, right? These are participating for the primary key, right? Those are known as prime attributes. And the other way around, right? Non-prime attributes. Okay. Right? Non-prime attribute means other attributes are falling into the category called non-prime attributes. That means those who are not participating for the primary key. Yes. Yes, very good. What are those two we have here, right? EMP name and EMP age. Right. So now we got to know about these two terms, right? Prime attributes, non-prime attributes. Right. Okay. Now we have that idea with us. Right. Now let's move back to the lecture slide. Okay. It says every non-prime attribute, right? A, right? Okay. In R is not partially dependent on any key of R. Okay. Right. Let's move back. Right, so now it is talking about the non-prime attributes, right? That means the attributes which are not participating for the relation for the primary key, right? Okay, now let's see. We have an employee, a different one, employee relation. Sorry. Employee relation, right? Let's say we have EMP ID. It's there, right? EMP name, right? And let's say we have department, DID, right? Okay, these two are the primary keys, and we have the name, okay? And let's say, yeah, that's it. Or age. Okay, look at this now, right? So we have employee ID and the department ID, the employee name, department name, and the age, right? Now, right, it says now what is, we have to understand, like there was another term, right? If you have like noted it down, see, partial dependency, right? We need to understand what is this partial dependency. They're mentioning that you cannot have any partial dependencies, and it's about the non-prime attributes, right? So let's see. Now, if we take this particular example, you could see, right, we have employee ID and the department ID as the primary keys, right? And here, like if we take this, like, okay, I'll like swap the places of the these two attributes. I'll take the department ID here. So now you can draw it like this now, EMP name. Okay, right. So now here, if we take this employee name, right? Okay, employee name, this is a non-prime attribute. Okay, this is because employee name is not participating for the primary key. So this is a non-prime attribute. And this attribute is only depending on the employee ID, right? It is not depending on the department ID, right? Okay, employee name is only depending on the department employee ID, right? Is it clear? EMP name we can identify by using the employee ID. Department ID is not going to do anything with this, right? Okay, so that means, see, this non-prime attribute is partially depending on this primary key, right? And look at this one, department name, right? Department name is depending on the department ID, right? See, department name is depending on the department ID. And think about the age. Age is not going to do anything with the department ID, right? Age is depending on the employee ID, right? So this is known as a partial dependency. Why? These non-prime attributes are partially depending on the primary keys attributes. See, right? Full dependency is this. Look at this one. Employee ID, NIC, employee name is fully depending on the employee ID and the NIC, right? Employee age is fully depending on the employee ID and the NIC, the primary key. The entire thing is the primary key, right? This is full dependencies, FDs, right? But here what we have not the FDs, we have partial dependencies, right? Half of the primary key, right? This employee name is depending on the half of the primary key. It's a partial dependency, right? Because primary key, it has like made with the employee ID and the department ID. So it is not a fully but dependent, like all the non-prime attributes are partially dependent on the primary key. So this is not the case of 2NF, right? So if you have a relation, right, and if you want to make sure whether the relation is in the second normal form, you cannot have partial dependencies like this, right? So let's move back to the lecture slide. I have a example there. Look at this. Okay, right? The relation name is employee project. That means we want to track the employees who are working inside the projects and what are the projects that they work for and the number of hours and all. And look at this one here. We have primary key, right? The NIC and the PNUM is making the primary key up, right? PNUM is the project number, right? And this is the employee NIC, right? And here we have a full dependency, right? See, this full dependency is there. Why? The number of hours are depending on what? The employee who worked and within which project, right? See, number of hours are depending on these both prime attributes, right? Hours of work, right? Who's the employee and what is the project, right? So here number of hours are depending on fully depending on the primary key. That's okay. But think about the e-name, right? Employee name. It is not depending on the project number, no, right? It is depending only on the NIC, right? And look at this project name and the project location. These two are not depending on the employee, right? These two are depending on the project number, right? So here this is in what? Maybe this is in 1NF, but not in second normal form. Why? We have partial dependencies. See, it says we have partial dependencies, right? So non-prime attributes are having dependencies. What type of dependencies? Partial dependencies, right? So if we make it, right, as a 2NF, okay, relations, right, we would get a separate table called employee. We need a separate table called employee. For that, we could have the NIC, that's the primary key, and then e-name. Okay, so we would have a employee relation, and we would have another relation called project, right? For project, we need to have PNUM, that means the project number, and PName, that is the project name, and the location block, right? And here we have hours as well, working hours. So that means we could have another relation called workload, right? For there we need to have who worked, right? That means we can identify it from the NIC. On which project, that means PNUM and hours. Okay, so these two would be the primary keys, right? And these two are foreign keys as well, right? NIC comes from the employee relation, PNUM comes from the project relation, right? So now these are in the second normal form. Okay, so children, is it clear, right? If you want to check if a relation is in the second normal form, first thing is what? It should be in the first normal form, and then it should not contain any partial dependencies, right? Partial dependencies means non-prime attributes are depending partially on the primary key. That's the idea, right? Is it clear for you? Yeah, I got a question. Just saw it, Hashini. Yes. When writing an attribute, is there a specific way to write it? Like any regulation, is it necessary to use the underscore between two words when writing an attribute? For example, EMP underscore ID. Yeah, good question. In your case, children, right, since you are providing answers for the advanced level paper, right, use the names that they have given, right? If they have given the attribute names by using the underscore, you have to write the exact word, exact attribute name, right? But when you're like into the computer science field, you can have your own naming conversions, right? Some are using underscore in order to separate the attributes, right? Okay, some are not using underscore signs like in order to separate the letters, right? The words in the attribute. Some are using something like this. This is known as the camel notation. We have like if we like now EMPID, no, the first letter. Sorry, the first letter EMPID, like this, right? Camel notation, right? First letter of the like word is capital, all others are simple. Or some are using like you told me EMPID, like this. Some are not using any underscore anything. But remember, when you are into database or when you are into programming, in order to separate two words, you can only use the underscore sign. Any other signs you can't use, like at, right, exclamation mark, hashtag. These we cannot use these things, these signs, right? These signs, they have special meaning when it comes to the databases and when it comes to the programming, right? So we can use only the underscore sign. Okay, so like here my advice is, since you are addressing the A-level paper, right, if they have given the attribute names like this, right, then please use the exact names. If they have not given the attribute names, if you have the, like, normally they are giving, I have seen, right, normally they are giving the attributes names. So if they have used all caps, go for all caps, right? Don't change the name, because I have seen within the marking scheme they have mentioned you're supposed to use the exact like attribute name that they have given. Okay, that's my answer. So is it clear, Hashini? Is it clear? Yeah, if they haven't given, then you can go ahead with any like naming conversion that you like. Anything is possible, right? If they haven't given it, then you can go with either like any like naming convention. Right. So anything that you want to ask? Hope it is clear, right? So we have completed second normal form, right? Second normal form. Remember, you have to satisfy the first normal form. That means you need to have atomic domains for all the attributes, right? And then, right, you cannot have any partial dependencies, right? Okay, all relations, they need to have full dependencies. See, full dependencies. E-name is depending on, sorry, E-name is depending on the NIC, right? See, project name is depending on the project number, location is depending on the project number, right? And NIC and the PNUM, hours are depending on these two like attributes, right? So hours, work hours, right? Who's the like employee and what is the project, right? Like that. Okay, so let's move to the third normal form. I told you these are steps, right? I told you these are steps. Okay, so because of that, right, in order to like satisfy the third normal form, you have to satisfy the second normal form first. That means you don't have any partial dependencies within your relation, right? It's for sure, right? So look at this. A relation R is third normal form if R, the relation, is in second normal form, and we have another rule, right? What is that? It says no non-prime attribute. Again, it is talking about non-prime attribute is transitively dependent on any key. Okay, it says again. Let's read it again and see. No non-prime attribute. Okay, our non-prime attributes we know now. Now we have another dependency, right? What is that? Transitive dependency, right? So let's see what is this. Right, I think like these terms are like maybe like very like not familiar for you, but let's see what is this, right? Okay, look, I'm directly going to take this particular example, and I'll take another example and show you, right? Look at this. Now, see, employee department table is there, right? Employee department table is there, right? So this organization using this type of a like table to store the employee details and department details, right? See, very like unfamiliar thing, right? So it is not normalized. No, that's the idea. So here, look at this. Social security number is the what, SSN is the what unique or the primary key here, right? Because we know, like in Sri Lanka, we don't have SSN, we have the NIC, right? But in America, they are getting each and every like individual citizen, they are getting this SSN, right? Social security number, right? That's a unique thing, right? So here SSN is there, it's a unique one, that's a primary key. And we have the employee name, we have the date of birth, right? And we have the address, right? And we have the department number, we have the department name and the department manager. Okay, right? Look at this now, right? We have like I mean, it says transitively dependent. Okay, let's see what is this, right? Now we know e-name is depending on SSN. Okay, yes, social security number having some kind of an impact with the e-name. And then date of birth, okay, yes, SSN depending on SSN. Address, yes. And which department the employee is working, yes, we can have this department number, because we need to identify, what is the department that the employee is working. And we have another type of thing. What is that? This department name is depending on the department number, right? Department manager is depending on the department number. Now what? Department number is not related to the primary key. It is not a prime attribute. See, you can see here we have only one prime attribute, which is the SSN, right? So department number also what? Non-prime attribute. Okay, it is also a non-prime attribute. Now what? The manager, department manager, and the department name, those two also are what? Non-prime attributes. So non-prime attributes are depending on another non-prime attribute, right? See, it's like very like unfamiliar thing, right? Non-prime attribute is depending on another non-prime attribute. So these dependencies are known as transitive dependencies. That's the name, right? Transitive dependency. Okay, we know the name, right? So what is this transitive dependency? Is non-prime attributes are depending on another non-prime attribute. That cannot be happen. Non-prime attributes always depending on a prime attribute, right? If it is a proper relation. But here, non-prime attributes are depending on another non-prime attribute. So this is not in the third normal form. If it is in the third normal form, you have to satisfy the second normal form, and then there cannot be any transitive dependencies. What is that? No non-prime attribute can be what? Depending on another non-prime attribute. Those types of dependencies cannot be applied here, right? So what we can do, right? So what we can do, we can make it as third normal form, right? So we can have a separate relation for employee, right? And we have SSN, right? That's the primary key, e-name, okay? And then date of birth, right? B-date, and the address. I don't have space here. And then the department number. Okay, department number, because we want to track what is the department this particular employee is working. And then we could have another relation called department. Okay, and their dnum would be the primary key. So this is what, then foreign key. See, this is foreign key. And then dname and department manager. See, so now we could say, okay, see, no, like the non-prime attribute is depending on another non-prime attribute. No transitive dependencies are available. right? So that means we could guarantee here we don't have any partial dependencies. So that means we can guarantee this relation, these two relations are on second NF, right, 2NF, and also no transitive dependencies are there. So these relations, those are in third normal form. That's the idea, right? What is this transitive dependency? Non-prime attributes depends on another non-prime attribute. Okay, we got a question. So let's see. Yes, right? Yes, Hashini. In this case, we are making the D number as the primary key, right? Because see, these two things are depending on the D number. That's this now in this employee department relation, it's just a non-prime attribute, but it has some kind of a significant behavior, right? It's a unique thing. So then we can have a separate relation called department, and then we can make the department number as the unique field. Then we have the department name, and the department manager is depending on this, like this department number. And this department number here, which is residing inside the employee table, that is a foreign key. See, department number is the primary key of the department relation, and it has gone to the employee relation, and it has become what? As the foreign key. That's the idea. So, yeah, any questions? Is it clear? Yeah. No, not like an assumption, right? Okay, not like an assumption. Here, we could understand this primary key, this particular non-prime attribute in this employee department, right? Okay, these two things. See, department name we could identify from the department number because it's a unique thing, no? Normally, right? Normally that's the case, no? Right? So here, department name, department manager, these things are depending on the DNAM, right? So you could assume that since these two are depending on this DNAM attribute, you can make it as a primary key. That's the idea. Okay, since these two attributes, non-prime attributes, are depending on this particular attribute, so you can make it as the primary key in the second relation. That's the idea. Okay, hope you got the answer for that. Okay, right, good. So another extra thing I told you, BCNF, right? It's nothing much, right? Okay, yes. Here the advantage of removing transitive dependencies, amount of data duplication is reduced, data integrity is achieved. What is that? See, if we are using the same table, something like the previous example which I have used, the lecturer table, if you can remember, yeah, this table, same thing, data redundancy. See, department number, department name, and the building. These two non-prime attributes are depending on this, right? So see, we have data redundancy. So we can remove the data redundancy, and we have the data integrity. See, the data consistency is there. I told you, I have explained this, right? So that's the idea. Okay. So Boy's code, it is not a very big thing, right? If you have done all the normalization rules, that means if you have done up to the third normalization form, then automatically you have achieved the Boy's and Cod normal form. It says here, right now, okay, let's read this. If a relation, right, if a relation, it is in the Boyce-Codd normal form, definitely it should satisfy the 3NF. And, right, every non-trivial functional dependency, right? See, this A is depending on X, hold in R, then X should be a super key of R. That means here, look at this. Now, D name is depending on dnum, right? Okay, and D manager is depending on dnum, right? And here, this dnum should be the super key, right? It should be a super key, right? This is a must. That's why now I told you normally, like if we have completed the third normal form, automatically the voice code is available. So don't worry, right? So see, this is the dnum is the super key. Yeah, it's understood, right? So here, look at this one. E name is depending on SSN, social security number. So this E name is depending on a super key, on the super key of the employee relation. That is what the voice code says, right? So if it is like your syllabus, we don't have this voice code. I just like teach you because like when you are like learning things in the computer science, you will like meet this. But normally, like if we have follow all the like normalization rules properly, right, definitely these things are available. In the voice code is available automatically in the relation. That's the idea. Okay, so can you remember now? First normal form, it's about atomic domains, right? You can't have any multi-values domains, right? Those should be atomic domains, right? Second normal form means the relation should be in first normal form and cannot have any partial dependencies, right? Third normal form means the relation should be in the second normal form and there cannot be any transitive dependencies. That's the idea, right? So is it clear up to that point? What do you think? Yeah, what do you think? Okay, right. So hope it is clear for you now. Okay, right. So let's move for a few questions because today the time is very limited, right? So let me exit from the right. Okay, here I have given like I have taken two questions from my end and I have taken 2020 question and the 2019 question as well, right? So first let's do a small question and let's move to the advanced level questions, right? So here, look at this. This is a very like easy one, right? A company uses the table below to record details of staff, right? Each staff has up to 3 qualifications. Okay, see, now each staff has up to 3 different qualifications, right? We can see that, right? See, it's there. Explain why this table is not in the first normal form. Okay, you can send me the answers. Quickly, you can use the chat. Why you saying that this relation is not in the first normal form? Yes, send me the answers quickly. You can use the chat. Why this relation is not in the first? Now remember, okay, recall the things that we have like learned. What is first normal form? Yes, multi-value attributes are presented. There are multiple values under the qualification attribute. Multi-value attributes are available. Yes, you can go ahead. Or here, we don't have under the qualification attribute, we don't have atomic domains, right? These are, we have what? Divisible domains, right? Okay, right. Your answer is correct. Good. Show how this table can be transformed into one NF table, right? So like it's really easy how you can transfer this into a one NF table. Definitely you need to have a column called staff ID. So I'm going to use the exact attribute names that they have given and the staff name. You better draw the table. Here I'm not going to draw it because like since I'm using the virtual whiteboard, it is difficult to draw, right? Qualifications. Okay, so if we take the S01, okay, Manga, and BSc, right? And then S01 again, because here we have another qualification comes under this particular S01, right? MSc, right? And S01, again, we need to write it, right? And PhD, okay? And then S02, Kumar, BSc, okay? And again, S02, we have another one, right? And then Kumar, right? And MSc, right? And S03, Grant, again BSc, and S03, Grant, PhD, okay? And in your case, right, when you're writing this, so tell me, what are the primary keys that we're supposed to like designate? Is it enough to have the staff ID, or like are we supposed to take a composite primary key? What do you think? Yep. Yes. Yes. Oh, staff ID is enough. Okay. Right. So if I make the staff ID as the primary key, you could see it is repeating, duplicating. No? If it is the primary key, we cannot have duplicate values. See, S01, 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 repeating. S02, S02, S03, S03, repeating. So is this enough for the primary key? Yeah. Is this enough? You have to think those things as well, because you need to show. Yes, we have a problem now. Yeah, we need a composite key, right? Okay, now what? What do you think? Now, is it enough? Staff ID, staff name. Is it enough? No, we have to make this one as the primary key as well. Now we have a composite primary key, right? If you're going to draw these, like if you get a question like this, you're supposed to like underline the primary keys. Please make sure to underline all three, right? Attributes as a primary key, because entire thing together, it's unique. See, S01, Ibanga, BSc, it's unique. That's it. Okay, separately, these attributes are not unique. So you are getting a mark for this as well. Okay, right. So let's move to the other question. Which one? This one. Okay, look at this. Sorry, yeah. The following table stores details of employees and the projects they work on and for how long. Okay, the following table stores details of employees and the projects they work and for how long, right? So here primary keys, employee ID and the project ID, right? This table name or the relation name is the workload, right? So here employee ID, employee name, project ID, project name, and hours per week, right? Okay, explain why the above table is not in the second normal form. Yes, got an answer. Yes, partial dependencies are there. Very good, right? So see, partial dependencies, right? This employee name is depending on this, right? Project name is depending on the project ID. Hours per week is depending on both things, right? Transform the table into second normal form table. So in this case, like normally, no need to write the data there, right? Okay. There in the A-level paper, I have seen they are asking you to not to write the data, just the relations, right? So then we could have a like table called employee. Okay. They have not given the name, so you can decide on the name for that, right? Employee, but they have given the attribute name, EMP ID. Okay, that's the primary key. And then we have EMP name. E-name. See, this is the camel notation, right? And then we have a project. You can go with project relation and then project ID. PROJ and ID. That's the primary key. And then project name. Okay. And then hours per week. These, that is depending on the who's the employee and what is the project. So you can go with workload. Okay. So that means EMP ID and comma project ID and hours per week. Okay, so these two are primary keys. So there are no any attributes for these relations, so you can close them, right? So here in the workload, right, hours per week, this one is depending on the employee ID as well as the project ID. Who's the employee? What is the project? That's the idea, right? So is it clear? These two questions are really easy, right? Okay, let's move for the 2019 question. I think this is the 19 one. I can't remember exactly. Yeah. Okay. So here you might feel like they have given a longer description, but here when you read it, there is nothing much available in the description. Okay. So here it says a vehicle rental company has registered vehicle owners, right? Okay, a vehicle rental company has registered vehicle owners, right? Vehicles are obtained from the owners and rented to the customers, right? Vehicles are obtained from the owners and they are going to rent it to the customers. The normal scenario which is happening in the real world, right? If you take a cab service, this is the process. Consider the following relations regarding the vehicle rental company, right? So here we have three relations. Look at this. Customer NIC, customer name, city, postal code, right? Vehicle owner is another relation. Owner ID, owner name, contact number. Vehicle is another relation. Vehicle registration number, description, and the owner ID. Who's the owner, right? The customer relation contains customer's national identity card number, which is unique. All right. So this is your paper, right? So you better underline it. Okay, this is the primary key, right, which is unique. Name, city, where he or she is living, and the postal code of the city. The customer lives in a single city, and there are many customers in one city. Yes, it could be happen, no, that there could be many number of customers, right? The postal code depends on the city. All right. So we are getting something now, right? Postal code, right? Okay. Depends on the city. All right. So quickly tell me, what is this dependency? Postal code is depending on the city attribute, right? What is this dependency? Yes, we got an answer. Transitive dependency. Very good, right? Transitive dependency. Yeah, right. Non-prime attribute is depending on another non-prime attribute, right? Next point. The vehicle owner relation contains the owner ID, which is unique. All right. Okay. Owner ID, which is unique. Owner's name and the contact number. Okay. Owner's name and the contact number. That's it for the vehicle owner relation. The vehicle relation contains the vehicle registration number, which is unique. Right. Which is unique. And a description about the vehicle and the owner ID. Okay. So that's it. No? Those are the things they have given. Right. Now, a customer can rent more than one vehicle because why they have given these things, because you're supposed to draw the ER diagram. I'm not going to do that today, right? So here, that's why they have given this additional information. Also, it is possible to rent one vehicle to many customers, right? At different instances, each vehicle is owned by one owner and one owner can have more than one vehicle. These things, one to many, these things, right? Okay, the question number 1. The part A. In which normal form do the above relations given in 1, 2, 3 above exist? Right? Justify your answer. Right? Now they are asking in which relational normalization form now these relations are available. Right? They are asking about the relation 1. See the first one, the customer. Relation 2. Relation 3. What is the existing normal form that they are asking? Okay, so let's do, yes, first one, and yeah, send me the answers. Okay, first one, first relation, the customer relation. What is the normal form? Existing normal form. Yeah, we got an answer. Yes. Here, first normal form, it is not talking about any multi-value attributes. And here, yes, here the what? We don't have any partial dependencies. We have a transitive dependency, right? So if it is a second normal form, that means the relation should be in the first normal form, and you don't have any partial dependencies, right? Here, this is not the first relation. It is not in the third normal form. Why? We have a transitive dependency. Once we remove this only, this will convert it to the third normal form, right? So that means first relation, we could say it's already in the second normal form, but not in the third normal form. Why? Transitive dependency is available, right? Second normal form, sorry, second relation, the vehicle owner and the vehicle, second and third. Yeah, already, right? We don't have any partial dependencies. We don't have any transitive dependencies. So definitely these two are on the third normal form. Both the tables or the relations are on the third normal form. Very good, right? We are getting answers. Very well. Right. Okay. Right. Now it says, so we have done with the question A. Done. Right. And then question B. Convert the above relations to the next normal form from the current normal form, which you have stated. Present the contents relevant to the labels, right? P to U. Indicate in the following table as you answered, right? So here we supposed to do the normalization, and then we have to tell, right, what is the next normal form, and then you have to write the relations which are available in the next normal form. So let's think about the relation number one, the first relation, right? The next normal form. Now it's already in the 2NF. So next P, this answer, P. What is the answer for the P? What is the next normal form for the first relation? Yeah, we got answers. Very good, right? Third normal form. Yeah, right. So yes, that means we're supposed to do the third normal form, and then we have to write the answers, relations. Can you type it and send it to me? Remove the transitive dependency and create the relations and send it to me. Can you do it? Just type it and send it to me. You can use your brackets and all, so no issue. Yes. Okay, here the city is postal code is depending on the city. So we can have a what? Customer relation. Use the exact terms that they have given. If they have given customer relation starting from a capital word, use the exact terms, right? Customer, and then we have to give customer NIC. They have used underscore there. So here, customer NIC. Yes, we got an answer. Yes, customer name. Yeah, right. Customer name here. Customer name, right? Name. I'm not going to close this. And then we can have another relation. You could go with customer city. Why I didn't put city? Because there cannot be the same relation name as well as the attribute, right? We have an attribute called city now. So because of that, I cannot use that name to the relation name, right? Okay, you can go with address. Good, right? No issue. So here I'm going to have the city, and see, this one would be the customer NIC would be the primary key. Here city is the primary key, right? So here city and postal code, right? So then what we supposed to do? We have to make the city as the foreign key here. Now we have a connection, see? Right? So then we would be able to identify the postal code of the necessary city, right? So here, this is how we can create the, we can make it as what? Third normal form. Okay, right. So these two are the answers, right? Q means the second relation form. What is the next? Q? What is the next? Normalization form for the second relation? Can we normalize it further? Don't talk about the voice code. Voice code is some kind of an additional thing. Can we normalize it? No, right? So here, very good. Here you can define can't normalize it further. Don't talk about the voice code here, right? Okay, further. And then, but you supposed to write the relation here, right? Write the relation here. So that means I can't see the relation. So because of that, I'm going to write the T here, right? T, you just write the relation, right? Vehicle owner underscore owner, and then owner ID underscore ID, and underline it, right? You need to show the primary keys and all, right? Owner name, you can write that, right? And same thing for the third relation as well, no? Can we like further normalize it? Third relation? No. Yes, we can't. Good, right? So again, you have to write R. For answer for the R is can't normalize it further. For you, you have to write it, right? And when you're writing, please note down the primary key. For that, you are getting marks. Okay. So this is the question you have like in the 2019 paper, right? So let's quickly move to the 2020 paper as well. Right, so this is the question. Here, I'll zoom in bit, right? The winner, this is the winner table. Given below contains the details of the players who won different matches and medals. All right, right? So here, winner table, it contains the players who won different matches and medals, right? There is a fixed amount of prize money given to each medal type. So here prize, like there are fixed amount of like what money for each medal type, right? That means the price is depending on the medal type. A gold medal has like 20,000, a silver medal has 10,000, and a bronze medal has 5,000. Right? Consider the primary key of the winner table is the NIC and the match ID. Now what? Right? So here you need to underline, okay, NIC and the match ID is the primary key, right? So write an SQL statement to display the number of players who won gold medal. So you know, like I'm not going to talk about this question. Let's see the second question, right? In which normal form does the above table exist? And justify your answer. Quickly tell me in which normal form do we have this particular table? Yes. Very good. It says here, right? Price is depending on the medal type. Note that, right? Price is depending on the medal type. So what is the dependency here we have? These two are in the like what? Primary key. These two are the like what? Prime attributes. So what is the dependency? Transitive. Yes, right? So if the transitive dependency is available, that means this is not in the 3NF. But we don't have any partial dependencies. So definitely this table or the relation, it's in the second normal form. How to justify your answer? You could say no partial dependencies, right? And but transitive dependencies are there. Okay, or you can just write transitive dependencies are there, right? So you could, if you need, you can draw this as well. Price is depending on the metal type. Okay, like that. Convert the above table to the next normal form. Okay, it is not required to write the data in the tables. Derive the next normal form. No need to write the data on the in the like, just write the relations. That's it, right? So how we can do that? Just send me answers if you can. Yeah. So we can yes, we can have a table called medal, right? And there we could have the medal type. See, the price is depending on the metal type. So we can make it as a primary key and we can include the price there. Okay. And then we can have the winner table, winner, right? NIC and match ID. Okay. And these two are the primary keys. And then we have to take this primary key as the foreign key. What is the foreign key? Metal type. Okay. Right. Now the relation is in the normal form, third normal form. Yes, good. Very good. Right. So that's about the normalization. So any questions from the normalization? Is it clear? Now, like, do you have any like compare yourself? Like, I mean, when you are before you starting the session, this particular session, right? Okay, the knowledge that you had related to the normalization, and then compare what is the knowledge level that now you have, right? Is it improved or what? Right. So like practice the normalization questions available in your past papers. So then you would be able to like take a good idea how you are going to do these things and all. Right. Okay. So any further questions? So next week, most of the time, another lecturer will do. Yes, Dahami, do you have a question with you? We saw the raising hand option. So, networking part, right? Network diagram and the subnetting, like those things. And after that, we can discuss other like topics that you all have given for us, right? Like logic gates, context diagrams, DFD diagrams. Okay. Yes. Do you need me to like explain the relational schemas? Okay, I'll note down that, right? So I'll do a session for relational schema as well. Any other content that you need to like revise? Apart from the we got that logic gates, context diagram and the DFD diagrams and the Python and the networking. That's it. So if you have any other requests, just drop a message and let's see whether we can do it. Okay, and let's do it. No issue. Right. So I'll talk about the relational schemas as well, for sure. Yeah. Okay. Any questions related to normalization? Yes. Right. So if you don't have any questions, so let's wind up the session for today, and I'll see you on next week, maybe myself or another lecturer for the next part. Okay. Right. So have a nice day and stay safe, everyone. Right. See you soon.